Once it says sent, tell me and I'll pull up my email and we'll be able to bring it up on my screen.
Okay. So I'm setting it as a large right now.
Okay, good. And just send, if there's more than one picture, the first time just send one picture. The more pictures you add, it increases the time it takes to get to me almost exponentially. You wouldn't believe it. Speaking of exponent.
Yeah.
Sending one picture should take like 20 seconds. Sending 10 pictures might take 20 minutes.
Yeah.
There it is. I got it. It's one I can download, which means I can get a hold of it and rotate it if I have to, or zoom in, zoom out.
Yeah, zoom in. So the top paragraph doesn't really matter. It's just like the story of it.
Okay.
But pretty much we're following these steps to get that graph, to write a function for that graph.
Okay, so you look at that. Okay, let me take a look then from the graph down. Okay. So all that's really saying is that you want to put the highest degree variable on the left, the next one next to it, and so forth and so on.
Yeah, and so far I've gotten through the first step, and I've done it on my calculator, and it's like every time I make a change or add something in to fix like where if it's positive or negative, then something else changes. So I haven't been able to figure out the ways.
Okay, what we're looking at is a hyperbolic function for sure. And it certainly has two asymptotes. And those asymptotes, it looks like you've got it correct, are x minus 3, x plus 1 as denominator. And then the question is we're trying to figure out the exact function, right? Okay.
Yeah.
We also have a horizontal asymptote where?
Just at, well, or x equals 0.
Y equals 0, remember? Y, in other words, horizontal lines are always y equals 0, vertical lines are always x equals stuff. I meant y equals something. Now, there is one thing worth mentioning about horizontal and vertical asymptotes. Vertical asymptotes can never be crossed by the function.
Yeah, but
okay. Horizontal ones can be, and also oblique ones. Have you studied slant asymptotes?
Yeah, we did. That was last unit.
Okay. And those can be crossed also. So it looks like we're looking at a horizontal asymptote of y equals 0 that does get crossed. And this tells you in the middle, the fact that it goes up and kisses the axis and comes back down.
Isn't that a squared on the x minus 1?
Yes, exactly. In other words, it has multiplicity that is an even multiplicity.
Yeah.
So either, well, let's see here. Let me think about this first. Let me read some of these things I hadn't gotten a chance to. There are two vertical asymptotes. Put them in the expression. Okay, and obviously, if I were to make those asymptotes look like this, in other words, if I were to say 1 over x plus, excuse me, hold on a second. Now let me back up a little bit. And let me move down a page. All right, so actually your answer on number 1 looks correct. There are 2 x-intercepts. Where do they show up in the solution? Put them in the expression. Okay, so x-intercepts come from y being equal to 0. And if you have y equals to a rational function, let's say that if I say that 0 equals x over z, that is only true if x is equal to 0. In other words, when you have 0 equal to a rational quotient, the numerator has to be 0. So we don't really care what the denominator is, but the answer you came up with there of x plus, well, it would be x plus 3 for the 0 on the left and x minus 1 for the 0 on the right, but the x minus 1 is what needs to be squared. Now, because of that multiplicity, remember if it's odd multiplicity, it goes through the axis. If it's even multiplicity, it kisses the axis and turns around. Now, so far we've got this, but there's a problem with this as an answer.
Yeah, so this isn't got on my own, but the problem is like when you put this into the calculator, the line on the left does not open up the right way.
Well, here's the first thing when I look at this right now, I know that the horizontal, there would be an oblique asymptote. Because if I were to multiply out the numerator, my highest degree polynomial would be x cubed, and in the denominator it would be x squared. So I need the denominator to be less than the numerator. Has to be less. What if we squared both of them? Now, we still have the same vertical asymptotes. This would put our horizontal asymptote at y equals 0, and it would give us 2 x-intercepts at the proper places. Now, you said when you put this into the graphing utility, okay, cool. Let me bring up my graphing utility and let's put in what we got and see if it's anywhere near. Are you familiar with Wolfram Alpha?
Not really. I usually just use my calculator.
Well, okay. Wolfram Alpha, if you're doing this stuff on a computer, is a fabulous, not just calculator, but knowledge database. The beauty of Wolfram Alpha is it will give you all of the zeros and everything. So let me put this in. We'll see what this function looks like. It also gives you the feedback of exactly what you put in. You know, some of these functions can be awfully hard to get in correctly.
Yeah.
Especially on that TI-84 that you have. Something that has a lot of parentheses can be brutal. Well, I think I may need parentheses on the top also. No, yeah, I might need parentheses. I think I'm going to put in, it's always better to have more than too few. Now let me see what it tells me this is. Let's see if I got it input right. I did. No, I didn't. Let's see. This one doesn't need the raised to the 2 power.
Yeah.
Okay. Now let me re-enter. All right, so that's what we tried to put in. And the question is that what we're getting? Is it the same? It's not the same as yours.
No.
Okay. Let's have a look back at their question here. In other words, our function that we came up with satisfies number 1, satisfies number 2, and satisfies the horizontal asymptotes. Use a graphing utility to check so far. Does it look like, notice that 1 and minus 3 seem to be the only real zeros.
Yeah, so after number 3 is when I put a square on the x minus 1.
Okay.
And then after that, I put that in my calculator.
Okay.
And it was not the correct.
Well, I'm looking at something else. Something else has to be true, and that's the y-intercept. Okay? And they've got the y-intercept at minus 4. Well, if we remember, the y-intercept is where x is equal to 0.
All the x's are equal to 0.
So if I made x equal to 0, I don't get minus 4. What do I get? I get, hold on a second, maybe I do. Let's see, I get 3 times 1 divided by 1 times 9. So I get 1/3. And that's why the graph that Wolfram Alpha had this middle piece above the x-axis. In other words, its y-intercept.
Do we need to put a 12 on the top?
Minus 12, perhaps. We'll see what that does. Yeah, because our y-intercept is at minus 4. So minus 12 should accomplish everything that we need. Let's try that. I should be able to add that minus 12 real easily here. And I want it right there. Let's have a look at it. Okay, I got the right function. The minuses switch the hyperbolic action. Put that one on the right and put the one on the lower right instead of the upper right. And that's what minus signs tend to do. Ooh. How are we going to solve that? Let me think for a second. We've got to make the y-intercept minus 4.
We could have just put a 12 on the top and a negative on the bottom.
What if we cube? No, that'll give us the same. In other words, notice what Wolfram Alpha showed me when I put it in. Oops, hold on. It gave me the minus out front. It didn't matter whether I put the minus in the numerator or the denominator.
Oh, yeah.
Okay. However, I'm thinking that there's other ways to produce that minus 4. Wow, although every one of them, let's see. We need one of these linear factors to be negative when x is 0. Problem. How about we square? No, we can't not square that. We could, wow. Let's see.
Yeah, I know my friends and I were stumped on that.
Yeah, let's take that minus 12 out, because that's going to reverse the hyperbola. But if we could produce the minus sign from one of these factors, that might give us the minus 4. Question is, how do we do that? Let's see. If x, x can't be minus 1. So let's eliminate these. X cannot be minus 1. X cannot be 3. Let's see. If x were like minus 7.
You want to diagonally separate x minus 7?
No, I'm sorry. I'm not sure what I was thinking there. We have to add different exponents is what we have to do. How do we get the bottom? In other words, is all we need the bottom to be is an x to the 4th, right?
Yeah, because we added in the x plus 1, the 2 squares on the bottom.
Yeah, what if we do that? In other words, what if we make, I think this is going to work here. In other words, the bottom is still going to be a 4th degree polynomial. The top is still going to be a 3rd degree. So our horizontal asymptote is intact.
Okay.
And when we let x be 0 to solve for the y-intercept, we do get a negative bottom. What do we get? We get 3 times 1 all over 1 times negative 3. So that would be a negative 1. So if we multiply the top by 4, that might do it. Right? That would give us, that satisfies all of our conditions, I believe. Let's input it real quick, see if that is correct. Hold on. Inputting these is not the easiest thing in the world, but there. I'm going to try to input what I've written there. Okay, so I want to back that up, put in a plus 4. And I want to change the denominator to the x plus 1 being cubed. And then this one to the 1 power, or I don't even need that, I guess. Okay, let's see what we got now. Okay, did I get it in there right? And it's looking pretty good.
Well, the one on the left's opening the wrong way.
It's just, it'll show it to you in zoomed out mode also here in a second. Hold on. There we go. In other words, that's zoomed in so you don't see the upper right quadrant, but this is zoomed out and you see that it appears to be doing very similar to what your function looks like. The differences in appearance, the differences in appearance have to do with the horizontal and vertical scale. Notice that your vertical scale is, 1 unit per hash mark, and Wolfram Alpha's vertical scale is 0.2 per hash mark. And then when they zoom out, their x is really zoomed out. Yeah, the only thing I don't like,
that left line is not going the right way.
no, it isn't. In fact, their two graphs don't agree with one another.
No.
This part right here doesn't agree with this part down here. The graph on the lower right appears to be correct, except I don't see this lower left part crossing that horizontal asymptote.
Yeah, and it kind of shoots back up, it looks like, too.
Well, from over here, yeah, I don't know. This one up here, there's something wrong with it. I'll bet if you graph this function in your calculator, it'll look very close to this, only it won't. It's got to cross through that x-axis.
Let me try it on my calculator real quick.
Yeah, try it. Here, let me put the function back up there in case.
Yeah.
Put that in your calculator. See what it looks like on a scale that you can control. That's the one drawback of Wolfram Alpha. If I paid their software fee, I'd be able to get access to all of it. But for free, they give you the two graphs that you get, and that's it.
Yeah.
Now, we know that it crosses that asymptote, has to, because the numerator is 0 when x is minus 3, and it goes through the axis.
Yes, that's kind of strange. X plus 1, 2.
Some of these rational quotients that are hyperbolic in nature, you know what I mean when I say hyperbolic in nature?
No.
Well, let's talk about that for just a second while you're getting that in there, not to distract from you, but this is your basic hyperbolic function, 1 over x, okay? And that graphs like this. It's a hyperbola. Have you had conic sections yet?
We had what?
Have you had conic sections yet? Ellipses, parabolas, hyperbolas, and circles? I don't think so.
Yeah, well, we had that. I didn't know that his name for it, but yes, we had that.
Well, the hyperbolas you study with conic sections look like this, or they look like this. Well, this one is rotated 45 degrees, but it is the simplest of all hyperbolas. And these can take many appearances. If you have two asymptotes, then they tend to look like this, exactly like the function we're looking at. And let's say I have an asymptote there. Well, it's going to look something like this, and then like that, and then in the middle it can do a variety of things. Sometimes it can go up like that, sometimes it will in the middle go up and turn around, and then the top left might look like that. So when I say hyperbolic in nature, I mean there's an upper right quadrant that looks like that and a lower left quadrant that looks like that. But if it's negative, then those are reversed. And I would be looking at something along the red lines instead of the black lines. In other words, that's also hyperbolic in nature, right there, that I just drew. Okay.
So I got it in my calculator. And the line on the left opens up still. The other two ones look okay.
The line line on the left opens up. You mean it doesn't curve and go back towards the horizontal asymptote?
So it's coming in from the left, and it just makes like a J curve up.
Ah, okay. After going through the point -3 though, right?
Yeah.
Okay, so in other words, your graph looks like something like, here, let me see if I can draw it in red real easily. In other words, your graph does this. And the bottom part goes up and touches the axis.
Yeah. So
something like that?
Like that, but the curve on the left is below 0.
Ah.
It's coming into it for a little while.
Okay, interesting. I think I know what's going to cause that and how we might be able to change that. So it looks kind of like that?
Yeah, it's pretty much like that.
Okay.
And actually, I think it might curve back up from below towards the horizontal asymptote on that left one too.
Oh, right. In other words, yes. It almost certainly does.
Yeah, so that's what we have right now.
So, in other words, it's the mirror image of what we're looking at in the problem. In other words, if we took your left-hand line and reflected it over the x-axis, we'd have something that looked pretty much like the answer. Is that correct?
Yeah, if we get that left one over, we would have the answer.
Question is, how can we do that with that function? How do we get that left one only to flip? That means so what they're saying is that when x is -2, y needs to be positive, right?
What? Yeah.
In other words, on your graph, or on this graph, excuse me, we need that when x is -2, y needs to be negative. Whereas my function that I've written here, obviously when x is -2, y is positive.
Yeah.
So how? Let's take a look at some of their hints. They must give you some way to do this. I mean, this is a very unusual problem. You said this was like a project? You have a while to do this?
It was actually giving us to us a couple days ago, and I have it due tomorrow.
Okay. Okay, I'm just reading 3. We got everything in 3 covered.
Yep.
And then 4, how did this change in multiplicity affect the end behavior and the asymptotes? What can you do to make your graph look more like the graph in this picture? Is the information you have so far consistent with the horizontal asymptote? Yes. If not, how should you adjust your function? We did that. Is the information consistent with the y-intercept? If not, do that. Well,
and that's all it gives me.
Yeah, they didn't really help. I mean, you could spend a lot of time graphing various changes in this function. I'm just staring at it, hoping that something will come to me. Let's go back and look at their definition of their rational function. I wonder if we put a minus sign here, what that would do. Unfortunately, at this point, Max, actually we're through the half hour, but hold on a minute. Let me just toy with some things. I mean, if my life depended on answering this question, I would just sit here and play with some different combinations, none of which are going to affect the x-intercepts, the y-intercept, or the horizontal asymptote. You know what I'm saying? In other words, you don't want them to affect any of those. See, when I put the negative sign, notice what it does to my two things. It switches them.
Yeah.
The lower right, or what was in the upper right, now goes down to the lower right. So that negative sign's got to go. I should have realized that, but I wasn't positive. You don't get a lot of practice, and it doesn't help that they graph this thing, and apparently incorrectly. They definitely graphed it incorrectly. Their top graph doesn't agree with the bottom graph. The bottom graph looks an awful lot like the Kardashian graph, except not on yours, but on mine it does, except it doesn't go through the x-axis at -3. And it does in this picture here. Oh, I see what's going on. Yeah, I see what's going on. Okay. These are consistent with one another. Yeah, this graph on the bottom has a part in this left that shoots back up and goes to positive infinity.
Which I don't think that we're even allowed to do.
Yeah, no, it definitely doesn't look like this. Well, this is definitely a challenge. I'll give it some thought, and I'm going to let you go now, but if I come up with any bright ideas, I'll call you back and give them to you over the phone.
Okay, so I should stay with the thing that the function that we have now with the 4
well,
and the x and 1 and the third, or should I go back and try and change it?
Well, notice what we're trying to do. We're trying to make sure that whatever we come up with has proper vertical asymptotes. This function does.
Yeah.
We need to make sure that the x-intercepts and the multiplicity is correct. Well, this function does, but this multiplicity x minus 1, that could be x minus 1 to the 4th. You might try that. In fact, let me do it real quick here. X minus 1, because that's still an even but if I do that, that messes with my horizontal asymptotes. Let me make that one to the 5th. Now I got my horizontal asymptotes correct. Let's see what this looks like. Wow. What did I do? I did something wrong. I messed it up. That might fix the problem. In other words, all you need is even multiplicity. And to be honest with you, that 0 at x equal 1 does not look like a parabola. So it doesn't look like it's going to be multiplicity of 2. I'll bet it's multiplicity of 4. I'll bet you anything it is.
Yeah.
Problem is, all of a sudden Wolfram Alpha didn't like that multiplicity of 4, or maybe they didn't like this multiplicity of 5. See, by doubling that from 2 to 4, I had to increase that from 3 to 5 also, because I don't want to mess with my horizontal asymptote.
Let me try putting that into my calculator real quick.
Okay, I also was thinking I could make this 3 and make the other one 3. Let me try that real quick also. Although it didn't like, yeah, and if I raise this to the 3rd power, that still gives us the bottom being bigger than the top. Yeah, I got it in there, right? No, it didn't, did it? It didn't on Wolfram Alpha either. Still has that J on the left, which is really an odd shape. I haven't seen too many hyperbolic functions that are like that. Okay, well, I need to give this more thought. I've never quite seen a problem quite like this before, where they try to get you to come up with the function. This is actually quite unusual also, the fact that the middle part heads towards negative infinity and it comes out on the other side of the asymptote from negative infinity. Usually they come from the opposite direction. That happens when you have something being squared with a negative sign in front of it. Anyway, Max, at least you've seen a chance to see how my online session works, and I'm sorry I wasn't able to come up with the answer to this problem, but this is a tough problem.
Yeah.
And it's one I'm going to have to look at for a while, and even then I'm not sure I can figure it out, but it's basically I'm going to do a trial and error basis. I don't know what else to do at this point. Just make sure that every different trial you use or try does not change the vertical asymptotes, the horizontal asymptote, or the x-intercepts. Those are or the y-intercept. There's 4 things that you have to make sure stay the same with every change you make. And those are the 4 things: the 2 vertical asymptotes, horizontal asymptote, and y-intercept. And the look of this one in the middle, I would bet anything that that's to the 4th power, not squared. Okay? So I would start with that, although, like you said, that doesn't seem to work either. I don't know. I just play around with it. Okay? Well, good luck on your test tomorrow. I don't know, turn in, if you can't get any further than this, and if I don't come up with a solution later on tonight and call you, I would say turn in as much as we have. Not this part here, but prior to that. Yeah. At least it shows that you satisfied the 4 conditions you have to satisfy.
Yeah, because it's kind of crazy the way she's grading it. A third of it is just if you got the right function or not. A third of the points.
Oh, just a third? Oh, in other words, you could get 2 points on the thing if you get the asymptotes correct and all the other stuff?
So if my explanations and my sketches and everything look good, then I could get a 66% if we don't have the...
Yeah. Well, I would not start from that point, but you know the point that we got to where...
Yeah, where it's with the third on the bottom, the square on the top, and the 4.
I think it was this one here. Yeah, that gives us the correct x vertical asymptotes. It gives us the correct multiplicity, and horizontal asymptotes, and y-intercept. So this satisfies 4 of the things. It just doesn't look like the correct thing. So
Yeah.
you might have to play around with that.
Yeah.
All right, Max, I will talk to you later.
Okay.
Okay? All right. Have a good one. Bye-bye.